I moved to Australia last year, around June last year, and I joined REA. Before that, I was working in investment bank called Society General that is in Bangalore. And I've been working in the bank for the last 5 years. So in the bank, my role was primarily as a developer and a technical lead working for the back office systems. So as many of you might know, in a bank, back office systems are primarily legacy systems. They're really, I won't say they are very bad or old, but they are not really loved. So you have a lot of new requirements come for the front end systems or the front office, and then there's a lot of pressure in the back office systems to cater to those front office requirements. And being legacy systems, you always have the pressure of delivery as well as pressure of maintaining the legacy code. And I'm sure many people here would be facing that every day, because with legacy code, you have to make sure that you maintain the existing code base, which might be really old, and add on to it with the new features. So in Society General, we always had this challenge of maintaining the legacy systems. And the legacy was really monolithic, it was huge. And being a bank, it was catering to everything in the bank. So it had the accounting system as well. So it was really tough for us to manage that, and we tried to do a lot of different things and implement all the agile processes there, but it was always a challenge. And with that background, I joined REA. So I was always kind of scared when I would hear the word legacy, because I always had that feeling that, okay, there will always be a code freeze, even though you say that you're working in agile. There will always be a code freeze because people are scared what will happen, what will break. We don't know what was there, we don't know what's going to happen as we go ahead. And in Society General, we had a 6 weeks code freeze. It used to be like 6 months, but with the good processes that we put in place, we were able to reduce it up to 6 weeks. So that was the kind of background I had in mind when I joined REA. And REA was a very different world for me. So just to give an overview of what real estate.com site is. So REA is quite a big organization in Australia. It is 43rd ranked in the top 500, Fortune 500 companies, and it is also listed in the Australian stock exchange. So it's quite a big organization. So we have different websites that we manage. So it's the realestate.com.au is Australia's #1 property site. So it helps for the residential properties buying as well as renting. Then we also have a real commercial website, which is used for the commercial properties. We have a couple of operations in other countries like Casa IT, which is in Italy. We have Microservices, which is in China, and then Square Foot, which is in Hong Kong. So as you can see, our front end looks very good. It has a lot of business all over the world. And then that's where my thoughts started running when I started looking at this, that okay, that means the backend is going to be a big legacy system, just like it is in a bank. So before we go forward, I'm going to explain how the REA business works in Australia. So in Australia, the real estate business is slightly different than the way it works in India. If at all I have to buy or give my house on rent, I cannot directly approach any of the property sites. Like in India, we can approach 99 Acres or any other websites and just put our listing directly on the website. But in Australia, a property owner has to contact an agent, and then the agent will publish the listing onto a website like REA and a couple of others which are there. So that's the way business works in Australia. So even though property owners are our primary customers, ultimately the real customers that we deal with are the agents. So there's always a middle person there when you have to put your house for renting or to buy on the website. With this, now in Australia, REA wants to change this model a little bit, and they want to shift the focus from the agents onto the consumers. That is the end users or the end owners of the properties. So the deal that real estate is trying to make with the different agents is that whenever a property owner is coming to sell or give a house on rent, We will also have certain, incentives given, wherein you have the electricity or the gas connections or all these other amenities provided along with the property. So that's where REA wants to move. Now that's where all our new horizon or the shiny new projects are coming into picture. Now, when we are saying new projects, that means it's going to be a lot of work for us, of course, and that means it's going to be a lot of pressure on the legacy systems because the legacy system has been built since REA started, which was 10 years ago. So just to give you an overview of our world today. So we have all our good websites on the front ends where people can see their listings. That is the real commercial, the realestate.com.au and other websites, which is like the shiny new world of good, the brand new things. And then we have our legacy systems of the CRM and the ERP and the accounting and the billing and invoicing and other things. So what do I call the CRM and ERP system and the legacy system? So can people recognize what this structure is? It's a Stonehenge. And as all of you would have seen on Discovery Channel and other documentaries, that Stonehenge is quite a mysterious structure. So if you look at this structure, people know that it was built, but nobody knows why it was built or how it would have been built. So our systems are similar to these. People have come and gone, new ideas have been implemented in the CRM and ERP systems, but we don't really know why they were there or what type of decisions were made in the past that caused this structure. So that's why we call this like our Stonehenge. And now, with all the new requirements that are coming in, we have to incorporate them in this structure. So this is quite a challenge for us. Obviously, with all the good knowledge that we have working with legacy systems, the standard idea was that we would build a standard interface in between the legacy systems and all the new services that we want to build. In a traditional architecture, what we would have done is just take the CRM or ERP system that is there, just build the interface and then add on some new modules in the same monolithic design. So that's the standard architecture that generally we would follow. And that's the architecture that I had seen being implemented in the bank as well. So you take a monolithic application, just add your new services or components in the same application. We would follow all the standard principles that are provided on how to work with legacy code. That is, keep the architecture separate, make sure that you have proper tests implemented, and also make sure that the interfaces are such that they can be extended. But in spite of having these type of standards, still the challenge remains on how do we ensure that the existing code would still work as I add features to it. So even though this was all well known, in REA we decided to take a slightly different approach. In REA we believe in the Conway's law. So the idea is basically as your departments are defined, so is your architecture. So in REA, the way our IT departments are structured is we have the lines of business. So residential would manage the real estate residential website. We have the commercial line of business to manage the commercial website. And then we have something called as group platform to manage the CRM and the ERP and all the backend systems that are there. So obviously with Conway's law, as these departments are formed, so are our applications. And we had to break this. So we had to make sure that whatever belongs to the residential side, the code or the subsystems are also managed by the residential line of business itself. Similarly, whatever belongs to the commercial websites, even the back office, even the back end, is managed by the by the commercial website itself. So with that in mind, we were looking at what would be that right architecture such that while we build these systems, we can even push the maintenance responsibility over to the lines of business. So the idea is the lines of business will manage the front end, the website, as well as they will start managing all the way to the back end where the bills are generated or invoicing happens. So we won't have one team managing just the invoicing and one team managing just the front end, one team managing just something middle thing that is there. So that's where we decided to go for microservices. So the idea of microservice in general is to have smaller services built in such a way that they can be deployed independently on their own specific servers. So it's not like a big monolithic application that is built and deployed, whereas you have different services that are built and deployed on different specific servers. So the benefit of this thought was that now, if we build a different service which is catering to a residential requirement, we can eventually push that service to the residential line of business and ask them to maintain it and add on to their features to that particular service, or to build similar services like those. So with this idea in mind, we started looking at what would be that definition of a microservice. So basically, how micro or how small should our service be? How do I decide that this is the right size, or this is the smallest component that I can build, which can be then deployed independently and managed independently? That is where we started looking at different principles on building these smaller microservices. So similar to how we have the single responsibility principle for any class or any object while we're defining, we decided to follow the same principle for a service. So the idea is, when I'm going to write one component or one service, it should have just one responsibility. So if at all I'm building a service to get data for, let's say, a contract from the database and just provide it, that's the only requirement, or that's the only responsibility that that service should have. It should not have anything more than that. If there is a requirement more than that, it should be built in a different microservice. It should not be built in the same microservice. The next principle is loose coupling but tight cohesion. So within the microservice, the cohesion should be really good, but the coupling between the two microservices should be as loose as possible. So that was the second principle that we followed. The third was each microservice should be self-contained. So the idea is the microservice should not be dependent on too many other microservices for anything. So the microservice should be able to cache its own data, should be able to provide cache data if at all the source database or the source is not available. So that way the microservice is pretty self-contained and able to perform its requirements without too much of dependencies. The last principle is no single point of failure. Now, as we are talking microservices, that means each component is going to be deployed in different servers. Now, imagine a system where there are like 50 or more than 50 microservices. If one of the components or one of the servers is down, does not mean that your whole application or your whole system is down. That is the basic principle which is followed today with Facebook or Google or many of the big companies. The idea is with multiple servers, at any point in time, some of these servers or a server would be down, but it should not affect the performance or the overall application that is running. So that is the principle that we followed, no single point of failure. So with these four principles in mind, we started designing our microservices and started implementing the new requirements. But again, there's a big challenge because many a times with developers, they are really enthusiastic and then we don't know where to stop. So that's something similar to this. As in the pattern, you can see that the person is asking for the salt, but a new system is being developed to do too many things, not just giving salt. That's where we decided to go for consumer-driven contracts. So the idea with consumer-driven contracts is that you should build just enough that is required by your consumers. So this, the principle that we followed with microservices, not to build libraries or huge amount of microservices, thinking about, okay, someday we might require this type of feature, and so we build a microservice for that. But the idea is, if there is requirement from a consumer, if there is a consumer who requires some type of a data or something, that's when we build a microservice. So just this is a high-level example. So we have a front-end application that we have developed. It's basically for signing of a contract between the agent and REA. And then the contract is signed. So this is the iPad application. So the idea is our the salespeople or the account managers or the relationship managers that we call, they go to the agents and then they ask the agent to sign a contract on the iPad, which is like an e-contract. And then that contract is sent to a service. All these boxes here, they represent microservices. So it is sent to a microservice customer acceptance. So what this microservice does is it will just take that contract and store it first. And then there is another microservice which is going to periodically read that contract and send it to the legacy system, which is our destination. So the reason why we decided, now let's see how all the four principles have been implemented over here. So single responsibility principle. You see, each of these components, they have single responsibility. The customer acceptance service has only one responsibility of just receiving the contract and storing it till the time the accepted contracts adapter asks for it. Similarly, accepted contracts adapter has just one responsibility of making sure that the contract is sent to the contract service. Contract service has just one responsibility of converting that data in compatible format, which can be stored in the destination, which is the legacy database or our CRM database. So each of these services, similarly, account manager service has just one responsibility of providing all the account manager details to the front end. So each of these services has only one responsibility. Secondly, if you see, each of these services are loosely coupled. So there's no multiple coupling happening between any of these services. Third, each of these services are self-contained. So customer acceptance, as it gets the data, it just stores the data. So if at all the front end is not available at any point, still whatever data has been stored is sent to the accepted contracts adapter periodically in an atom feed format. So even if it happens that accepted contracts adapter goes down for some time and it comes back up, because it's a field, it will go back and make sure that the data is sent to the last sent record. So that way, it is self-contained. And the fourth principle is no single point of failure. So even if some of these services are down, it doesn't matter much because from the UI, from the user point of view, the contract reaches a customer acceptance, and if it happens that accepted contracts adapter is down, it doesn't matter much because it is going to be stored with the customer acceptances. And then whenever this will come up, it is going to pull and periodically get the data and send it to the database. So at each point, we make sure that there's no single point of failure. The data is self-contained and it's provided as required. So with all of these, there are a lot of challenges that we have faced. So let's look at first challenge that was there on how do I test the integration between all this. So generally in any testing mechanism, if I have to test the integration points, I would try to mock some of the service. So for example, if I have to test customer acceptance and accepted contracts adapter integration point, I will mock either of the one. So if I'm testing the provider, I'll mock the consumer. If I'm testing the consumer, I'll mock the provider. But then that still doesn't guarantee that I'm testing the real system. I will have to have the environment ready to test the entire end-to-end application. Imagine this is just like a thin slice that I have shown with all the different microservices that I have. We have more than 50 microservices. And one end-to-end system can encounter more than 10 microservices. So if I have to test one thin slice or one business process end-to-end, that means I have to have the 10 microservices running in my QA environment every time. So in order to overcome that, we decided to go for PATs. So like JP Rensburg has mentioned, integration tests are scam. And this is something that we encountered initially because it was always a challenge for us on how do I decide whether the current thing that I'm developing will work properly with all the different microservices that are already there in production. Every time we had to have those microservices exact versions running in the QA environment. And then there might be some new requirements implemented in other microservices. Again, we have to make sure that those are there in our Q environments, and it was always like a race condition for us. And that's where we realized that integration tests are always going to be a challenge. So we do follow a continuous delivery model where we have the code, we have the unit test, but instead of the integration and the acceptance test, what we have is the pact-based testing. So what exactly is the pact? So like I mentioned earlier, if I have to test an integration point between the consumer and the provider, I will have to have both of them running simultaneously in my environment. But instead of that, what we have proposed is we can have something called as a pact broker. So the idea of the pact broker is to have the contract published from both the consumer and the provider to the pact broker. What the pact broker does is whenever the consumer testing is happening, the pact broker will act like a provider and it will return whatever is the expected schema or the expected format of the response to the consumer. So for the consumer, it's as good as having a provider running in the environment. Similarly, for the provider, if I'm testing the provider, my pact broker will work like a consumer and it will send me the expected response. So this, for the provider side, the consumer is like, the pact broker is like the consumer. So effectively, I'm achieving having both consumer and the provider running in my environment, even though they are not really there, even though it is being replaced by the pact broker. So the idea is pact broker will work like a record and replay. So pact broker will record whatever is the expected request and the response from both the consumer and the provider, and it will replay it whenever it is being used for testing. So this way, we ensure that the real testing happens, not really using mocks, mocks can be used only at the unit test level. And for the integration test, we replace the actual provider and the consumer with a pact broker. So we have the open source link for the pact broker. So there's a Ruby module created, Ruby library created for the pact broker, which can be taken from the real estate website.
The very first time you run, you actually need to have both of them. Right?
Yeah. Sorry?
The very first time you run, you need both.
Yeah, so basically, when I'm coding for the provider, I can actually publish those contracts to the pact broker. So if I'm developing for the provider, I publish the contracts to the pact broker. When I'm developing for the consumer, I publish the contracts in the pact broker. And also, if I want, I can configure it in such a way that it will connect to the real production environment and get the contracts. So then you can actually test with your the code that is under development with how it will work with the production code on the other side. So you can also configure that. So basically, if I'm writing the code for the provider and my consumer is there in production, then I can use the contract which is coming from the consumer in the production environment to test my provider.
That's for the legacy systems. If you're developing a new system.
Even for the new systems.
It's the same contract, so probably you just provide the.
Yeah, it depends on. Yes, it depends on how your teams are structured. So, for example, if one team is only writing consumer and the provider, you will know, right? You will always have to write the provider before you put consumer into production, because otherwise.
There is nothing in production.
Right.
New system. So.
Yes.
But there is a contract. There is a interface. There is a protocol.
Right.
So you just publish that protocol with that.
So if it is JSON based, then you publish the JSON, whatever your schema is there, with the pact. So the pact will then help you test your consumer or the provider.
The pact is a kind of stuff and purely needed for the testing purpose.
Yes, it is just for the testing, but it's not.
To replace the stuff.
Yes, exactly. It is not the stuff. Right. Because the idea is, if you see, this is the real provider and the real consumer which will be publishing the samples or the whatever the expected contracts to the pact, right? It's not like a mock. So I'm not mocking out my consumer and then publishing the contract to the pact. My actual consumer itself will publish the contracts to the pact. So pact will always have the exact contracts that are there. And you can configure the pact in whichever way you want to use it.
It doesn't define response every time a consumer or provider.
Yes, because it is only for testing. So, and for the actual testing, you can then have both the things running in QA environment or even in production. But this will give you a confidence that this provides exact response like how your consumer will provide or how your provider will be working.
There is one thing. So every time there's a new contract, so how do we ensure? So is it like a developer responsible to publish the contract, or is it in some automated way that the pack receives the new contract?
Every time, yes.
Every time the contract change or a new contract added, how do we ensure is it a developer personal responsibility or is it something automated?
Yes, it is because it is a developer's responsibility. Because how will the pack know that it is changed? Right now, we have not had that mechanism where pack will discover that it has changed. Otherwise, it will have to poll every time, and it would be difficult to poll in a development environment.
Because again, there is a problem if the consumer is down, if the going happens,
Exactly.
then comes out.
Yes. But then if you are a developer and you know that your contract is going to change, you don't have to bother testing the provider because you just publish the contract with the pack, and whenever the provider is being tested in the continuous delivery model, it will fail anyways because it will now not comply with that contract, right? So that way you don't have to have the responsibility that you have to test both the sides simultaneously all the time. It will be taken care of as a part of the continuous delivery.
Can you maintain version?
Yes, you can. With
Different version.
Yes.
You have the contract. One thing I'm not understanding is how does it give you back an HTTP response? I mean, where does the data come?
So the pack broker runs like a service. It runs like a microservice. So whenever you are running your tests, you will connect to the pack broker and get the request, get the response back.
But how does the pack broker know what data to send? It knows what the schema is, right? But what
Yes. So it will have a sample request and a sample response along with the schema. It just doesn't match the schema. Right now we have not done to the data level, like exact whether it is a string or a number or those type of things. It's not done to that level. But if you want to use it in such a way that it has to match with the exact response, it can be done. It is there, but it's not. It's very rudimentary. It is not done to the level where okay, I say that it is my response is a string. We are not checking that. What we are checking is the format, whether it contains those parameters.
So you do have the schema and
A sample, yes.
data.
Yes. So yeah, it does a basic test. But if you are looking for whether my response has a number or whether my response has 6 digits in string or
What
is
I
a
was
number.
worried is that it needs to figure out the data
Yes.
somehow. and
Yes.
At least if it has the
It
data.
is not done to
it
that
is
level as
set.
of now.
Does that mean it's more of a static data than?
Yeah, it's static data that's sent for every
Right.
request you're going to get the same
Yes.
data.
And also this is actively being developed, so new features like these would still be coming.
There's a commercial tool called Lisa, which is used for this very purpose.
Okay.
It's very extensive and very elaborate, but it's a commercial.
Right. And this, I think now we have it in Java for JavaScript as well as for Ruby as well as for JVM, Java as well.
Okay.
So there are multiple, it's there for multiple languages.
So your consumer test, the pack is not transparent, right? You need to know that you're going to run against the pack. So is there some configuration change? How do you know you're going to go with the pack?
I have given, it's actually for the pack, this is a complete different session.
Okay,
So yeah, I completely understand your question. And there was 1 hour session given in Yao West by Beth, who is like the custodian of pack. But
Sure.
if you are interested, we can, because yeah,
No,
it's
go ahead.
I can
Go ahead.
explain the whole
Yes.
thing, but it's like a completely different session for packs and how it is done and what are the challenges that are addressed. This is just a high level.
Absolutely. Go. Sure.
But it's good that there's a lot of interest, and maybe I can request her to give you that session because she's like, she breathes the pack thing, so she will be.
Beyond the URLs.
Yeah. So with all these microservices, and the next topic that I want to discuss is custodianship, or how do we maintain it. So it's very easy to say that you can have all these microservices, just write new microservice whenever you want. But then this is also going to be a legacy one day. So how are we not going to fall into that trap of legacy and then be scared to touch anything or change anything? So the concept that we follow is you build it, you own it, and team managed infrastructure. So we don't have different teams to do the release and different teams who are developing and different teams who do the QA. So the concept that we follow is the team who is building it is responsible for releasing it in production and maintaining that application, that microservice in production. So we have different roles to do that. So we have a role called a sheepdog or a dingo. So the dingo role is to make sure that whenever there's a pager or Nagios alert or any type of alert coming in production, he has to address it, and that role is rotating role within the team. So we have a DevOps kind of a model followed in our teams. And the idea with this as well is as we build microservices, we want to give that responsibility to the corresponding lines of business. So eventually, whenever I'm building a microservice, let's say, which is going to be catering to a commercial line of business, I can just give that responsibility to the commercial line of business to maintain it, to manage it, and they will be owning that microservice completely. So we are still in trying to figure out the custodianship model that we call. There are a lot of challenges in that because we have teams where microservices are owned by we have microservices which are owned by different teams, and that's where the challenge comes in because then who would be the custodian of that microservice? So we are yet to figure it out, but we are in the process of getting there. So that's on how do we maintain and scale this model. Now, talking about scalability, it's like I said, it's very simple to say that, okay, we start creating microservices, but of course, we don't want to spend days together on getting the basics right and then actually writing the code. So when I'm saying basics, things like how do I deploy it? Or how do I have the logging? How do I make sure that my Nagios is configured? How do I make sure my Splunk is configured? How do I make sure New Relic is configured? Or how do I make sure that if I'm deploying it in cloud, I don't have to have all those challenges of how to go on cloud and then actually create an instance, deploy my microservice. So all these are all the basics which are pretty much standard across all the microservices that we are building. So that's where we have something called as a stencil. So the idea of a stencil is like a template. So the basics that are required are there, provided upfront when I'm trying to create a microservice. Now, how did we arrive to the idea of stencil? So we followed something called as the rule of threes. So like in any in photography or in any statistical models, they say that whenever something is happening 3 times, that means that it is something that can be extracted and taken as a common thing, or it can be taken up as a template. So we did not start upfront with a stencil. So there was nobody in the team working on I want to create a template for microservice. What we decided was let's create a microservice. Let's copy that and create another microservice and see what are those commonalities that we want, and then create a stencil out of it. So that's how we evolved a template or a stencil for our microservices. So even today, the way we work with stencil is, if at all I have a new requirement at a template level, I will not put it immediately into the stencil. I will wait for that requirement to happen 3 times when I'm creating 3 different microservices. And then we understand that, okay, that means it is quite common, and then we abstract it and put it into the stencil. So that's how we have got it just right, and it has worked pretty well for us. So the way it evolved was initially we started with a stencil which had the database connectivity, Nagios logging, and no UI, because most of our microservices were kind of a middle layer or a backend microservices. But eventually, when there were a lot of requirements coming for our UI, we built up a stencil for a UI microservice which did not have anything to do with the database. And then we had another microservice, another stencil created for different languages. So today we have microservice stencils for different languages like Ruby. We are in the process of creating one for Golang. We are also looking at creating one for Angular. and one for JavaScript as well. So that's how we are evolving the stencils as we see that it's now just right to create a template. So with all these microservices and all these different types of things coming in, it's pretty possible that in a system, people might get lost. Or if I come into an organization or I come into a team and I see that there are hundreds of microservices, and now I have this requirement and I think that, okay, maybe I will have to write 101th microservice. How do I decide? That's where we build something called as a treasure map. So the idea with treasure map is not really giving documentation on microservices. It's more like giving a map or a direction to understand what are the different microservices which are existing in our ecosystem today. The way we have evolved treasure map is just not giving the map of all the components, but also giving the map of the business processes that are there in the ecosystem. So it gives twofold view. One is the business processes that have been implemented with all the different microservices, and then what are those microservices which are taking part in the business processes. Again, as with the challenge of documentation, is the biggest trap or pitfall is documentation generally gets obsolete pretty fast, and all the developers will know that nobody wants to write documentation. So the way we are developing this module is it actually has self-discovery feature. So eventually we want to reach a point where my microservice will just register with the treasure map, and after that treasure map will make sure that it has the latest information coming in from that microservice. So the type of information we are looking at is not only the business process which the microservice is participating, but also the usage of that microservice. So if at all it is not being used for a couple of days, it will give an alert. You'll see an alert in the treasure map which will tell that this microservice maybe is no longer used, and then we can actually make it deprecate it or maybe move it somewhere else. Similarly, the idea with treasure map is that it will always give you the live data. So it will give information like who is the custodian of that microservice. Also, it will give a little bit description of the microservice. How many GitHub issues are there in that microservice? When was the last time it was deployed in production? And what is the latest version? So with this information, it will be very easy for the team to understand how frequently the microservice is being deployed in production, how frequently it is being used, as well as where it is being used. So this is also another component that we are looking at open sourcing eventually. This is one slide which I wanted to share just to give an idea of what are the different tools that we are using when we are building microservices in REA. So we are using Asgard, which is open source tool from Netflix to manage Amazon Web Services, because all our microservices right now are in Amazon. We have AngularJS for our UI. We use Golang, Java for different microservices along with Ruby. We have Docker. We use Nagios and PagerDuty. We also use Neuralink, Splunk, and so Vagrant. So we have a lot of things being used. So just to summarize my talk today, I think some of the key lessons that we have learned in our journey is, first is it's important to identify the granularity of microservice. We should understand how micro we have to go when we are talking microservices. Second lesson that we have learned is we should evolve the service template. It has helped us immensely. Last year when we started building microservices, it used to take us around 1 month to build one microservice. Today we can do it in a couple of hours. Packs are the way to go. It's a big lesson for us because we struggled a lot with testing between different microservices. Delivery engineering, that's basically DevOps and having team owning the infrastructure. That has helped us, and that's the way we are following today. Production is the best test environment. So if we are frequently releasing whatever we are developing, we can actually test our application in production better rather than spending our efforts in building a QA environment with all these microservices that are there. And with frequent release, if at all we find that there's a bug in production, it's very easy to roll back that one microservice that we have released and not causing too much pain or too much trouble with the whole environment. Self-discovery of microservices makes it easier. So that's where we have evolved our version app, which helps us to understand what are the microservices that are currently running in our environment and whether I have to write a new one or I can reuse the existing one. So, yes. So these are some of the references for PACT. There's a Twitter for PACT as well. And there are a couple of open source projects from real estate, which is there available at the website. And some of the other references.
How different it is from a service-oriented architecture? This is service-oriented architecture, maybe more granular, but
Yes.
What are the differences other than this being more granular?
I'm not very knowledgeable in service-oriented architecture, so I may not be able to answer your question upfront, but I don't know if Ketan and Jesal might.
It is the way of doing service-oriented architecture.
Yeah. Other than that, I mean, is there anything? I'm just going to be wrong.
Service-oriented architecture, at least from my understanding, one of the differences is that each service typically connects to a central database. Right here, you're talking about each service having their own database. So that's one kind of thing that really stands out in my opinion. Which means you can have heterogeneous databases, each service using its own type of database, which at least service-oriented architecture does not stop you, but nobody really talks about it.
There are database boxes or other databases in each box. Probably I think it's one central database.
No. The idea is every microservice will have its own specific database. It's not central database at all.
So it's an application of data duplication.
It encourages data
It encourages data duplication. Yes.
redundancy, right?
Yes.
You want redundancy, so that when something goes down, you can still work off the cache.
Yes.
Second question is how micro you go, because I mean, if you create too many services, it's chaos.
Yes.
So where
So
do you start
that's-
and how do you decide?
Yes, so that's the whole idea that, like I said before, we decided to go with single responsibility. So generally from a business process point of view, we looked at what is one responsibility that I want to have from a business process point of view for one microservice. And then eventually, if you look at my previous so eventually, if you see this contract service, right now it is just writing into the database. So eventually we may have another service just to read from the database. So that way we also have the segregation between the read and write. But today we don't have a requirement to read the contract from the database, so we don't have a service. But we can then decide at that point whether we want to have a different microservice depending on the type of business process that we want to implement. So we have to look at the business process as well when we are printing out the microservices. And it is a challenge, and I totally agree with you that it is the biggest challenge that we are facing is how micro should be micro. But if we are having certain basic principles already defined, like single responsibility, or we know that we don't want to have a single point of failure, so then we can then decide whether it's required to have a microservice or we can use the existing microservice in that case.
So it's a very important question, and there is a big debate that is going on actually, like how micro it should be actually, because there is no perfect definition of a microservice.
Right.
But I think to answer the question, I think you can watch James Lewis and Martin Fowler videos actually, and same sort of questions have been asked in these kind of forums actually. So you might.
Academia likes this.
Okay, yeah. So, but I think that it was the same set of questions were asked in the forum.
That's the biggest struggling right now.
Yeah, exactly.
In general learning.
Like
There's a huge cost overhead. Right? Every time you define a new microservice, there's a cost overhead of development. There's a runtime cost overhead. So you have to make that conscious decision.
Yes. You have numbers on maintenance cost? You have numbers on maintenance cost? No, not really.
so you have to define it.
No, just a comparison like one monolith, so it kind of thing versus.
The other thing about SOA is no one actually talks. SOA, almost you assume that all your systems, all your services are, are consistent in terms of the data. Here there is eventual consistency because things might be down, so your whole system is not actually consistent. So that's another thing where you have to see if this is really suitable for your nature of application, because a lot of people who've gone down this have regretted because they realize too late that it's eventual consistency. And that's a huge.
If you're duplicating data, then it's not consistent, then who wins? That again is the question. So,
Also, it's very evolving. Like, you cannot predict you'll go with these n of nodes.
Yes.
As you said, time to time review whether
The-
something gets done.
The standard principle for anything in REA is treat everything like cattle, not pets. So don't treat even your microservice code as a pet. So if you think now the work is done, just destroy it and create a new one, write new code and just use that. So that's the standard, fundamental principle behind microservices as well. So like I said, if later on, when we have new requirement around even contact service or anything in this picture, these services might go away and then new services might be replaced. So yeah.
Twitter is one company which is kind of known as the poster child for microservices right now, and they've had a lot of grumbling inside as well about it. So it's an evolving thing. I think it's interesting to see where it's going. It's certainly giving people a lot of ideas around to think about how they structure the services today. I mean,
and service-oriented architecture is way to go. It is all this legacy, but this is taking it too far. At least as far as
I remember when service-oriented architecture came, people said it's taking it too far.
so
we don't know where we're going to stay.
But if you see,
10 more years and we will know where it is.
with cloud, I think it is because infrastructure has become so easily available and it's simple to spin up new instances. I think that's where we find this to be a major benefit, because I can spin up an instance like in a minute. I don't even have to wait for a server to be ordered or anything like that. And then I can just have my microservice running there and keep destroying them and recreating them.
Is it recommended that each microservices runs on a separate instance, or
Generally, that's how it is. I think that's how it is being implemented.
Yeah, it depends. So, generally, ideally, we have two boxes for each of the servers for balancing the load type or the
Right.
traffic that comes up. Generally, we prefer one microservice per server.
So how does the overall testing thing work here? Because each microservice will have its own release cycle and own test cycle, and then when do you really do end-to-end tests?
That's where we are looking. We are following testing in production primarily because we release so frequently that even if something is not working, we can immediately roll back and have the previous version running.
That's the production is the real testing, end-to-end testing.
Yes, end-to-end testing. But we do have, for certain cases, we do have a QA environment set up. But then it's the break even is not achieved that much. So it's too much of effort to maintaining QA environment just like production environment. Especially given that if we are releasing like every day, twice or thrice in a day, it just doesn't make sense.
So I think to answer your question, we are just going to present like how we actually tested the microservice application.
All right, thanks.
Okay, so I think Supriya talked about what are microservices. So basically, before we start, what we are going to talk about is like the testing strategy or rather I would say a functional testing strategy for a microservice kind of architecture. So before that, we'd like to give a brief overview about ourselves. So I'm Ketan, and I come from a company called ThoughtWorks, and we have been working for a project which deals with this kind of architecture for the last couple of years. And we have tried certain things that we are planning to present today. And for me,
I'm Jesal. We in ThoughtWorks started a couple of years ago, and yeah, we're working around with it.
So I think Supriya pretty much covered what a microservices and so I think I'm just going to skip some of the slide actually but the example that we are going to take to explain what are the style that we chose to test microservices. Like for example, if you talk about an e-commerce system, let's say if a user want to purchase a product from an e-commerce system, actually what happens is, let's say for example, I'm just talking about this, let's say this is your microservice kind of architecture where you have your each service. For example, you have your card service, authentication service, your catalog service, or your say payment service. So as she mentioned, you have this set of RESTful services which are talking to each other in order to allow user to purchase a particular product in the cart. So for example, if I want to add a product, it will actually call to make a call to a catalog service saying that okay, this is the product that actually I want to purchase. So catalog service is actually responsible for serving the product that is required for the customer to buy. Now, when he chooses a product, he actually places that particular product in a cart service. And once it makes a call to, when we navigate to a payment page, it makes a call to a payment service, which is just responsible for saying that okay, what to accept the payment, and it will make a call to a third-party system that you see over here, just to authorize the card details that has been entered by that particular user is valid or not. So this is our ecosystem. This is like a third-party system that we are using, for example, to edit a card and logistic once we ship that particular product to a customer. So this is like the example that we are going to use to show us in like what are the things that we try testing for this kind of architecture. So yeah.
So here, as Supriya mentioned, there's a distributed system complexity. So a lot of times each service can be owned by a team. A team is working on that service, right? So testing becomes a challenge because if some team has changed something, how do we ensure that the other services are working fine? And then there is inter-service communication. So as Ketan said, these are really RESTful services, and communication happens via set sort of format. So in our case, was a JSON response request. We also had asynchronous. So some of our services were asynchronous in nature. So we have background jobs running. So if suppose a customer would place an order and buy something, he or she would get an email or an SMS saying thank you for your purchase. So these are really asynchronous jobs that would run by shared communication service. And then there's dependency management. How much is one service dependent on the service? What happens if something is not, if one of the services is down? When we took a step back and we said, let's talk about testing strategies. So there are some of the things that we came up with. So a top-down approach, wherein we go from a whole end-to-end user journey. We automate that. Then we, as and when, come down and go to the modular levels. These kind of tests turned out to be, and this is how our tests were actually initially, and these turned out to be brittle. We have slower feedback, and maintenance cost was really high. Then another approach was a big bang, and this means so when your application or feature is ready, go and test it that time, and nothing before that. Let the developers finish developing. Let's go test it after that. And in a hybrid or a context driven, well.
It's a mixture of both, like top down and like that. Yeah. And so when we talk about the top down and bottom, it's more of a testing pyramid that we generally choose. You start from unit and you reach to a unit layer, or rather UI layer, and other way you start from a UI layer and then you reach to a unit layer kind of thing. So we started with the top down approach there, and we had a lot of we used Gherkin-based features or feature files. So there was like a lot, so the cubes which were floated around, and as you mentioned that UI tests were actually really brittle, hard to maintain, and there were like so many tests that were failing constantly. So it was a nightmare for us to maintain those set of tests actually. So yeah.
So is it the fragility of the UI that was a problem, or the evolving understanding of what needs to be done was a problem?
Yeah, so basically the way we started writing queues was like we started writing queues for each and everything that was available in the UI, which we thought that later on, if we tried another approach, we could be could be tested later at the bottom layer, for example, integration or a service layer or something like that actually. And we did not thought about it earlier, and we just tried to automate everything which was at the UI layer. There was nothing else that was available for us at that point in time. So
when you say bottom up, what do you mean? Sorry, go ahead.
So I think that is going to
be. Go ahead.
So
when we came up with the bottom-up testing approach, we were actually testing the domain. As you would have seen in the previous slide, there were different services. So there's a card service, authentication service, payment service. These are really domains. So our test, we wanted to have tests around the domain, right? And hence you're testing closer to code that is being developed. So if there is some new requirement, you know that when you run the existing test, is there something breaking from it? And this helped us integrate pieces earlier rather than testing it in the whole UI. It's a very late feedback cycle. And we used mocks and stuff. We'll come into some of the next slides where we used mocks. And as Ketan said, we focus on the test pyramid. So we push a lot of tests down the pyramid so we get faster feedback. And what this helped us was we could visualize and categorize our test better, which services tested, has better coverage, how is it working all in totality and things like that.
So yeah, I mean, when we talk about test pyramid, this is the test pyramid that we're talking about, and I hope everybody is following it. So it's mainly that we divided our test into this set of layers, and generally, if you talk about these two layers, they are not like a different layers, but they are actually at the same level. But this is something we actually start, like, when we say bottom, we started over here and we reached over here. So the advantage of this pyramid, as you know, you have like lesser number of UI tests, which is like, the maintenance nightmare becomes less, you have like less brittleness, and you have a very set, like few set of tests actually, where you try to cover as much as over here, unit test or a contract layer, whatever you can actually. So that's the focus that was there by testing this kind of services that we paid for our application. So when we talk about unit test layer, it's mainly testing the domain that we generally develop for each of the models that we have in place. It's mainly focused on the code under test and try to have like maximum test coverage as much as we can for a given set of project. So if we take an example of a card service that we discussed earlier, let's say if you have a method for say add item, remove item, or verify credit card, you try to write tests for each of the method with possible combinations, positive, negative scenarios, whatever edge cases that you can try. So you write all the combinations and try to test at a unit layer as much as you can actually. So it's mainly the unit testing that typically we do for each of the models that we write.
Each of these are microservices, which means each of them had their own database?
Yes.
So would you test with the database or without the database?
No, it was without the database.
So you would mock out or stub out the database?
So yeah.
So as we mentioned, there are contracts between each service, right? And after the unit layer, we had one contract test layer, and we tested one endpoint at a time. And in this, we treat the service as a black box. So we will hit that endpoint, and we should get with a particular request. In our case, a JSON HTTP request, and the response should be a JSON HTTP response. Just quickly, so suppose you're testing the cart service, and what we want to test is adding an item to the cart. So if it's a post HTTP request, we send the request and we expect the JSON response. In this case, we're testing the contract, and all of the other services are mocked out if in case there's any interaction that will be required.
So if this service is dependent on this service, we generally mock out on this service, and we just test only one endpoint that has been exposed by this particular service. And we try to test this service as a black box. We don't know what is going happening inside. All we do is that these are the set of parameters that has been that is the contract that has been exposed by this service. These are the set of parameters that we need to test. or send. We just send those parameters and expect a response back from that particular service. So this is how we actually treated each endpoint that has been exposed by a given set of services.
Yeah, as I said, assertions were based on the response and we used to from the data. So an end-to-end integration.
So I think you asked a question about like how do you take care of end-to-end integration thing. So here, as you see that there are multiple services that are being built actually. So how do you test the interaction between each of the services? Because at the bottom layer, like when we talk about contract layer, if there was a dependency, we used to stop or mock out those dependencies. But here we actually need to actually test the real interaction between the real services that is there. So like the idea is to basically test the. So what we initially did was like identify the end-to-end user journey basically. So what the user can do, but not through a UI. So identify end-to-end user journey. So for example, here a user is there. A user creates his own account. User chooses his product, places into a cart. Make the payment service, make the payment information, and then fulfill the rest of the services.
This is still at the layer of services.
Sorry?
This is still at the service layer.
Yeah, service layer. There's no UI interaction level. Yeah. So yeah, I'll just talk about this. For example, so earlier we talked about this service and we used to mock out all these services basically. But here we are actually testing the interaction with the real services that we have in place. But rather than testing only two services, we used to identify the end-to-end scenarios. Because what happens, otherwise you have like too many combinations that you have in place and you end up duplicating the test that you test for different components. So the reason why we wanted to avoid that was, that it is a maintenance segment.
Thin slice through.
Exactly, for each of the services that we have in place.
And this ties back to the fact that when we had a lot of UI level, when we tried top-down approach, and then we had a lot of tests on UI tests, right? So this layer actually helped us bring things down and avoid that or have faster feedback left. This was the key.
Yeah. So like basically this covers interaction among all the available services that we have in our ecosystem. So it's mainly the UI set of tests, but there's no UI involvement.
Yeah, but this can still form the basis for the UI.
Yes, exactly. Yes. Okay. And the best part is like it's not brittle, it's fast. You can test the way we want, and it's easy to test actually. So like one thing that we forward actually. So you can also see these are the third-party systems that we are using for these services, and we mocked out this particular thing. So how do we even test this particular things actually? Because this thing actually resides outside our ecosystem. So in case if they make any changes in their system, how can we ensure that their changes is not affecting our set of services that we have deployed in our ecosystem? So
I'm seeing things like master are to be very critical, right? So
yeah.
So we identified some set of tests, and again they were also exposing contracts which we would be using. So we came up with these set of tests which we are running on our side using their test server, and also asked them if they ever have they deploy something new and they have some changes, they would run our tests in their systems also, just to say that we are in sync.
So for example, this is the service, and they have exposed an endpoint to validate the details. So what we need to do, we have this contract in place. We write all the set of tests that we have in place based on the contract that has been exposed by this third-party system. So whenever they make any changes in their system, we used to either give the set of tests that we have written to them, or they can log into our CI server, run those set of tests, and make sure that nothing is impacting our system. So that's how it used to work actually for testing the contract.
So when you say they, who do you use it?
Third-party systems, actually. Third-parties with using whom we were interacting. So that test servers.
Like cc.net, something like that. Like cc.net, something like that, or
cc.net is like I don't want cruise control.
Not the gateway.
the gateway.
Mastercard provider.
No, the provider actually.
So you're directly talking to the provider.
Yes.
But providers would actually come to like HDFC Bank or CCLTD or something like that.
Oh, you would interact with the gateway, so this will interact with the payment gateways.
Yeah, correct. So the payment gateway providers is not MasterCard directly, right?
Yeah, I mean, currently they have, in fact, I mean, the example that
Yeah.
probably the payment gateway and payment service is the same.
Yeah, there is only one provider. Assuming that there is only one provider in place, this is the third-party system they are using. I got your point actually. What you're trying to say is that they can come via different endpoints. It could be SSA, MNU, or HDFC.
We have multiple endpoints there, and
Definitely.
each one having a different
interface
itself.
Right. Yeah. But they must be exposing their set of contracts, even if they are coming from different routes, right? So we can.
Like a simple example I'll give you is you have MX, so you have a different endpoint they would expose.
Yeah.
Then you have Visa and MasterCard, that's a different endpoint. Right? So let's say your consumers could pick whichever.
Yeah.
Now let's say PayPal, just to complicate, you have three different things, right? So you have to validate against all three.
Right. So basically we need to identify the set of contracts that is related by all those three systems and write test according to them. So, yeah. The more the number of third-party systems that you use, you have to make sure. But the major idea is to basically write a test for those third-party systems, just to make sure that their changes is not affecting your system. So that was the whole point.
My experience generally they don't care about you at all. Right?
Yes.
Yeah.
That's not.
Why would they run your test?
No, but we used to run our so if they used to deploy any they used to make any changes in that system, they used to deploy it in that test servers. We actually used to run that set of tests, our set of tests that we wrote for them actually, just to ensure that their changes are not affecting our things basically. That's why. Or otherwise, I would say it actually helps us in debugging the problem. If something fails, we know, oh, this test are failing because there is a problem in their system and not in our system.
No, absolutely. There's a huge value in doing that. The only thing is that usually, if you're talking of actual payment gateways, they don't care about running their test at all. They're like,
Yeah.
What they do is they give you a test server, right? A test environment. So against that, you can keep validating,
I agree. So mainly the last layer that we had was like the UI layer, as you mentioned. So it's a same set of end-to-end user journey, but it's more of a happy path user journey where you interact with the user interface that has been developed using front-end systems. So the major idea over here is to keep the UI test at a minimum, have only 2, 3, or 4 scenarios in place. For example, in our system there were only four scenarios in place, and it used to test everything from end to end, right from step 1 to step 10 kind of stuff. So that's mainly about it actually. So you see over here, earlier we used to test everything from using services at the end-to-end integration layer, but now you have UI layer that is introduced between here and this test actually. So you come by UI, you test everything, whether whatever is required is working or not, and then see things are.
Here you don't mock out anything, you're actually running against.
Even these are the real instances that are being used over here.
in their test environment.
Yes, test environment.
Like you're not actually making a card payment to it.
No, it mainly test environment.
So there's still a chance that something could go wrong.
Yes. And that is the reason why we have this layer in place, so that you see.
No, I'm saying even after this layer, there is a chance that things could go wrong because the versions in their test environment and the production
environment is different. So that is like a kind of trust that we have to so yeah, I mean, basically we need to make sure that okay, the same version of that particular build is there in production versus the stuff that they have in test environments. They have to be in sync actually.
So typically, we have a practice of having either the service layer test against the master card where you have, we would run that when we go on production. Or we would have one test, which is what we call as the deployment tests, which will actually run in production against those tests.
So we have that set of tests, we call it like a smoke test or sanity test kind of thing, where you actually make the card payment and make sure things are working fine. But in the end, we just cancel the order, for example, in this case, and then make sure that the real it has the same version of the system that we actually tested at the bottom of the table. So yeah, that's how we ended up testing the real production systems that they have here. So yeah.
And just some more things. So I think as Supriya mentioned, logging we found that important. So every service should have the right kind of logging mechanisms because debugging will be easier to find out where the actual problem is. And so if your service affects with one service is down, can we literally have 50 errors? Is our whole application still working? So we have to, this is something we sort of did manually for now. We brought one or two services and see how things are working, still working fine or not, and if not, then let's fix those things.
Yeah.
And then a bit of look and feel of the application.
Manual testing or expert testing.
So microservices, when some other service is down, ideally you would be working off the cache.
Yeah, provided we have a caching mechanism in place.
I mean, to me, that's one of the core things about microservices.
Yes.
They're more resilient when
Right.
something goes down.
Correct.
So would you automate that?
We haven't automated that. What we are doing is that testing it manually, actually bringing one service down and see how it is actually impacting our application, the services that we have in place, how it is reacting. As she mentioned in one of our slide that if one system goes down, it was still accepting the customer information into the that particular service. So that's something that we really test.
Typically, a developer would have tested the caching logic or things like that. So I'm hoping that it would have also got tested at the lower layers at some point. But you're kind of making sure through some exploratory testing and make sure that's really good. Can you tell a little bit more about logging? I'm just curious, like what kind of things would you check?
So ours was the case as in like if there are this set of different like 10 services in place, for example, if the user chooses to do like one end-to-end scenario and if something fails in between, we used to log like everything in one place. So he started with this thing, he did this, it did this, it did this, and then if something fails, then you have like at one point at one place you can figure out okay what actually went wrong, and then you can look at the logs of that particular service and see what were the actual failures that were there in that particular service.
Like in our case, the way we do it is we use Splunk. So generally we log with IDs. So it's easier to looking at the Splunk logs. It's easier to actually link the outputs or logs from different microservices in one place. Because then Splunk provides you a lot of features. You can search, you can index, you can also give keywords in your logs itself. So even though you have different microservices deployed on different servers, each log would be published in one set of ways in Splunk, and you can link it.
In our case, we used a extension of error rate. So the single error reporting mechanism would always go there, and that would shoot out email notifications if something went wrong. Over there, see even do the service and find out.
And also measures, so you have measures
Alerts.
Many of the services is failing, so you immediately get a page alert.
So yeah, Splunk is
This is more of trace logging is what you're doing, not other kinds.
One is the other kind would.
So trace logging is essentially you want to trace what is the journey through, right? There might be logs in terms of what is the memory footprint.
Oh, okay.
So this is mostly trace logging.
Memory footprint of each server and things like that. We use Noodle for our. We use Noodle.
So not at the server level. So some places where you know something sensitive, you might put start and end time, how long
Service takes to report it.
things like that. I mean, this is not trace logging, which doesn't have to do with a user context. It's independent of a user context. While this is more tied to a user context and trace logging.
So that was done mainly in the performance testing on an API that we did for each of the endpoint that was exposed by service. So we did that, but we have not covered over here actually. Yeah, that was separate. Yeah, usually provides the basic information. Is it running out of space? How much space does it have? Or is it running out of memory?
It doesn't do per service level inside the service. So it does at a request level.
Yeah,
Request level,
but not at each instance, right? So yeah, as she mentioned, Splunk is more of a commercial tool, but we also use something like Kibana. It's just an open source tool that has come up as like a central logging aggregator, where it makes all items to trace back what actually went wrong. So you can just find out.
You touched upon performance testing. I was curious for micro testing. Will your performance testing strategy change? What stage do you start with performance testing?
Yes. So basically, so there was a requirement from a customer. They wanted to migrate some of the customers from their legacy system to a new system that we would have using microservices. So every time they come, we need to actually handle or support like this many number of users that we need to migrate. highway. So based on that thing, we used to identify certain endpoints that okay, using these endpoints, those like the endpoint which can become a bottleneck. So we used to do the performance testing of that particular endpoints, which is to we used to make sure that whether that particular endpoint can actually handle that particular kind of load or not. So that's how we used to test. So we used Gatling and JMeter for that actually.
But when you're developing new services, right, so what you're talking about is when you're migrating, you're not necessarily consume. But in general, if you're building a new microservice, I'm assuming there would be some kind of performance metrics around it. And at what stage did you start doing?
So actually, as soon as you develop one endpoint, we generally start doing the performance testing of it. But depending on it, like if two services can be tested together, we try to test those two services together as well actually. And we used to have like the benchmark in place. So if it goes beyond certain thing, that we used to make it red in our CI server. That was the benchmark that we had in place.
So we had an environment where we deployed one version of the app, and post deployment we ran those performance tests with the matrix that you mentioned. And if it was going beyond that matrix, then you should run alert saying that okay, someone go ahead and see if it's fine, is it very critical, and take that decision. So something like that.
So our performance tests are also automated. So whenever you check in something, it used to run those sort of tests, and if it goes beyond that particular matrix, it will just fail. So you actually need to go back and optimize that particular endpoint, as in like what went wrong after introducing this particular stuff.
The interesting thing about performance testing in the microservices context is that when everything was on the same server and I was just calling a whole bunch of things, right? Inter-service interaction had no latency technically, right? And if I did an end-to-end test, I'm good to go because I knew this is roughly what my performance would be. But with microservices, when we are talking about caches kicking in at various levels, we're talking about distribution of services across servers. There's all kind of latency, there's all kind of other things that is going on. So, what are the right levels? Because I'm assuming you need to do microservice level performance tests, but then you also need to make sure latency doesn't kill you.
Yeah. So we haven't done the end-to-end yet actually, but what we have done is generally mainly using the each service that has been exposed by a particular microservice. So
endpoints have been tested,
not end-to-end. So yeah, as of now that's the case actually. But that is the plan that we need. That is the plan that we are going forward with doing the end-to-end testing for performance testing of the end-to-end flow actually, and see how things work actually.
So let's say your customer had a request that it should not take more than 3 seconds for the whole process to go through. For example, this required calls to multiple. Then you probably would start with that in mind.
Yeah, so I was also thinking the same way. From customer perspective, he's interacting with one place, right? He's not worried internally how the application is structured. So when we said when you said performance, I was actually thinking end-to-end performance.
This starts getting interesting because a lot of people build microservices when they think something is performance intense, so they want to make that a microservice and then cache a lot of stuff around that, right? That leads to creating a microservice, but that's one of the decision points generally. And then you need to have some kind of measure that after making the microservice actually improved, or it's made it worse because of the latency and other kind of things that come.
Yeah, another point I would like to make is the example that Supriya gave us. The iPad application actually dumps the contract in the next service. And since it's a microservice, it will store it in its database and then just return back. The iPad application doesn't care whether the contract is in the next immediate service or has reached the legacy system, CRM system.
Correct, that's a good point in terms of, that's where microservices are generally a strategy for improving performance because you break it down that way. But you're lucky if you're only interacting with one microservice at a given point in time. There are many cases where you actually interacting with multiple microservices.
So in this case only, if you want to purchase a product from e-commerce system, you have to go through each flow, and some of the things are asynchronous and they are not yet synchronous. So you have to go via each services. For example, for car service, it has to make a call to a catalog service to fetch the product from a catalog. So that thing requires a performance testing from end-to-end perspective.
For example, an order summary page would really be tracking the card, your payment, a lot of different things. So, so you need to identify those boundaries.
And when we say performance testing of end-to-end, it's mainly using services and no UI actually, because UI can be done via profiling thing and all.
Generally, the UI is still under your control,
Yeah.
but network and other kinds of things are outside your control, and that's where the fear, the unknown is there.
And it also depends how your microservices are being deployed, because in testing environment generally you try to deploy all the microservices in one box, but in your pre-prod or a production kind of environment you have a separate box for each of the services that you build. So,
And some might be extremely critical, so you might have 10 of those deployed and do some kind of round robin or whatever between those services. Now, again, you need to, in your case, you test that in production, I guess.
No, we do have QA, but like I said, we are using Amazon Web Services for everything. So even our QA environment is in Amazon Web Services. So it's exactly like there's not much difference for us. So when we're doing the testing, generally for performance benefit, we use the QA environment. It's just another account for us in Amazon.
Okay.
Just in that account, that's where we test it. But it's a little of a challenge for us because our legacy systems are actually in a data center. They're not being migrated on the cloud. And so we have to look at network dependency, like you said. So that's where we decided to use microservices as well to split connectivity between the end system and the iPad application and the systems. So then that's how we manage that.
So you have multiple layers of cache.
Yeah.
I mean, so it gives you the.
So we have kind of split the SLA for a user, which would be like a couple of less than 5 seconds. To the level where okay, it's still less than 5 seconds for the application, but it's like up to an hour for us to really have the data into our systems. Because most of the times, if you ask any user, when do you want, or what is the rate at which your data should be updated, or what type of data you would like to see. Everybody wants to see the latest, the most
Instantaneous.
But instantaneous, exactly. But if you see, they don't really care that much. So that's how we also manage that SLA for the end-to-end.
yeah, that's about it actually. This is the set of references that we use for defining the testing strategy for for microservice architecture. So that's about it.
Any other challenges in terms of testing which are very specific to microservices, which probably you've been faced before?
Infrastructure testing. How deployed, like what sources of discoverability, all those things. So that was a major challenge actually. Because earlier if you're on the system, you just deployed one kind, and then it doesn't work, you know that where you have to go and see what is the point of it. But here, 10 different things deployed on different boxes. There's something called like, or maybe there's a mounted device on some of the systems, so you see what things goes well. And so basically debugging is a bit pain actually, where things fail anymore. So that was a major challenge that we faced earlier, but now that's not the case with the traceability logging in place.
Understanding which versions are in production and actually testing
Exactly.
against
So versioning is a bigger space right now. I mean, we haven't identified a solution. Like if you have made a different version of APIs for each of the services, how do you test that actually? That's again.
Yeah, so your test environment should be same as production for all microservices.
Yes, for us it is a little bit easier.
Theoretically, people argue that the whole concept of microservices is that your versions are backward compatible and all of that stuff, so it should not matter in theory. But I think that's a lot of teams struggle to get there because backward compatibility, I mean, we've not figured that problem out in 50 years of computing.
Yeah.
Having this microservices actually is good for achieving that pyramid, right? That's what I'm saying.
When you say pyramid, I don't know.
Test pyramid.
No, I think test pyramid can be applied for any set of projects. It's not that Here it was like just an intention to focus on the test. That was.
I see what you're saying. I think it makes sense because the things are broken down, right?
Okay.
While
Yeah.
if you think of something as a large monolithic thing, generally testers have the attitude that if it's this one big thing, I'm not going to poke into it.
Right.
I'm just going to do end-to-end test, right? But now that you've broken it down and you're saying here are explicit contracts, now there's a tendency that I can actually go one layer below and start testing it. So from that point of view, it's a that's in my opinion. Yeah. But the overheads have to scale.
Exactly.
Managing all the versions, managing the infrastructure, having so much infrastructure available itself is a big challenge.
And like basically, we generally developed a client for each of the. So we made all the services available, and we had a client gem for each of the services. So if you used to upgrade your service, for example, so you have to upgrade your clients. Basically, when you test, you might be testing with the older version of your service. And if you upgrade that particular service, you have to upgrade your client and then try to test along with those.
The whole underlying premise of SOA or microservices was all about loose bundling.
Yeah.
But I don't think we've actually achieved that because you still are very tightly coupled to the client needing to know what version the server is and working with that, which means they need the contract or whatever to feed them. So I don't know if you really solved the decoupling problem in that sense. Yeah. Between services to some extent,
yes,
but between client consumers and this thing, I don't think.
There is no OSD equivalent kind of a thing there. So it's GI equivalent kind of a thing.
Oh,
Unix pipes.
Unix pipes. I think the microservice actually is based on that.
Inspired
by pipe actually. That do one thing and like everything should be a pipe to another set of commands. So that's the philosophy behind the microservice.
So if you had to do this again, would you use microservices or not?
Well, I think we have a lot of learnings. I think the way you design your microservice, I shared like how micro you can go, it's still the biggest challenge because we have faced that when we say single responsibility, we actually struggle to identify whether it's the responsibility of this service or this particular service. And we tried putting things into one of the services and then at the end of the day we figured out, oh, this particular service is actually bloating up. Now is it the right time to actually split it into multiple services or not? So that is a biggest debate that is actually going on. And like it's a very difficult thing to answer whether should we even split it into multiple things or not. That's the biggest. So for me, I think we are between SOA and microservices because we are not truly microservices as you said. It is more of a decoupling, and here we still have some kind of dependency on two different services. Not all the services, but at least two or three.
To answer your question, we definitely want to, at REA, we definitely want to go this route because it enables experimentation.
Yeah.
So, for example, if today there's a new technology or new language coming in, we can write a microservice and test and see whether that's the way we want to go. So it gives us tremendous power to do this type of experimentation, be it infrastructure, be it tooling, be it language, be it whatever. So that's how if you see 6 months ago we did not have single microservice in Golang, and today we have 3 of them. And people are like, yeah, we feel we want to create a microservice in Golang, let's just do it. And if you want to use instead of microservice, we want to use something else. Or for example, I said iceberg. It's very easy for us to move things across, whether it's tooling or whether it's whichever pattern we want to use. We are not constrained because we have a monolithic application and now we cannot try out different things.
So developer flexibility, but business,
Yeah,
business agrees to.
So the integration testing becomes a major challenge over here actually. That's right. But for business, I don't.
They don't care whether
Exactly. They don't care whether you do a monolithic system or a microservice.
It's kind of it is a business because at least they really encourage us to do a lot of experimentation. And this is we are able to give them the whatever result, whatever requirement of feature in that same amount of time. Then where they expect. rather than saying that, okay, because my monolithic application is in Java now, I have to cater to Java itself, and I cannot find a good spiking option.
So one of the reasons, like one of the argument that I had was like we can use microservice architecture in an application where you have your different set of products, and if you, let's say tomorrow you want to introduce a new set of products, you just like take 2 or 3 services together, couple them, and then it becomes a new product for you actually. So that's where I think microservice might be a more useful thing about
Product composition, yes.
So if you have 10 different services and if you want to introduce new product, you can say, oh, these are the different services. Like take those things, build a product, and release it to market. So that in that way it becomes easy.
But achieving that kind of a generalization is very difficult in real world. I mean, each application is different, so each nuance of Excel itself. I mean, you can think of maybe logging service and maybe payment service and card service, but yeah, in reality,
Infrastructure related stuff, you could see working that way, but business logic.
If you see the new requirements that are coming in where we have to go for a contract between the providers, the service providers, like electricity or gas connection. It's a completely different ballgame because I have never worked in that. But then with microservices, it's easier for us to develop a contract management, another microservice just for that purpose. And then I don't have to disturb my existing CRM, or I don't have to because it's a third-party product that we are managing, whether I have to go for a new version of that product or to create another product. It still gives me enough time to do all that research and see which would be the best CRM to go for in the future. I don't have to wait for all that research happening before I can start catering to the customers. And basically for the parts of the system which are under flux, kind of. Because that's always the stable parts maybe isn't good or bad. The question is stable parts, yes, I understand that from developer perspective. No, even from business perspective. Yeah, so I mean, from business perspective, as well, we develop these parts which are evaporative, so that they are experimental. Good. What about parts which?
It might not be these solutions, but the interesting thing is that I saw in her presentation, so something common that we also had. So she had a legacy system, right? On top of that, they were building and how. So we also had a very similar thing. I think what I'm trying to say is it's not the solution, but it's one of the solutions to solve existing problems and take things forward.
So
yes, business
dependent on the legacy system too much. That's
So mushrooming pattern that I think Michael Feathers talks about it. So getting the legacy code that keep poking out little mushrooms, keep mushrooming out and pull things out and then let the existing system stay. But new stuff just goes out.
Again, there is I don't know, you have heard of like a one-page app that is like single page app that is like quite hot in nowadays actually. And for those kind of apps, they are generally building this microservice kind of architecture. I've seen those sort of applications.
They don't really need to be microservices.
Ideally, yes, but they just wanted to experiment and like how things work if you want to develop. Because there was nothing like a jar that was actually being developed, like deployed. It was just a static page that was getting deployed. And then the rest everything was actually covered by the microservices that were there in place.
This one question is this the new decom? I don't know. This is distributed comp factor, this idealization of components and
History repeats itself.
Thank you.
Any other questions? Alright, awesome. Thank you guys.